Hello everyone, welcome to week 8 of problem solving session for NPTEL course, uh, problem solving through programming in C. And so in these sessions, we actually look at some quiz questions, which are multiple choice questions. And I give you time to read the question and then try to answer it. So there are 10 such questions, and after that there are 4 programming questions. So let's get started with that. Okay, I think you can see the problem number 1 on your screen. So the question is that what is the output of this given program? So this is the program. There is first a hash include stdio. Then inside the main you have these blocks, where you in the first block you're defining variable a and assigning it value 70. Then in the second block you are printing the value of a and then you return 0. And these are the 4 options, and you have to tell that which one of these options is correct. So,
I'm option A, ma'am.
okay. Okay. Any other answer? Okay, that's a good try. But option A is actually not true because these set of braces, curly braces in C, they are used to define blocks. So if you, and that limits the scope of a variable. So scope of a variable means the region in which that variable can be used. So when you define this variable a inside these two curly braces, this can be used only in this block, only between these two curly braces. If there is, and also the nested blocks inside this block, but it can be used, its scope is limited to these two. These are like the boundaries, and outside this it is not visible. So since this printf statement is outside the set of braces, and in fact in another block, which is not necessary, even if there was not a different block here, if you try to print a here, now the compiler will give you a compilation error. That is an error while you try to compile this program. It will say that a is not, like a cannot be used here because a is not declared, because it has not been declared in this scope. So there is no a variable which it can see here, which it can print. So the answer is C option, compilation error. Okay. Malam, is that clear?
Yes, ma'am.
Okay. So moving on to the next question. Here, the problem is asking you to choose the options that are correct in C. Okay. And so option number 1 is that a function with the same name cannot have different signatures. Different signature means it's saying that you cannot have two functions with the same name. Okay. Signature, I think, means that how do you declare a function? You say, okay, int foo, and it takes two parameters, int a, int b. So that is a function signature. So it is saying a function with same name cannot have different signatures. Option B is a function with the same name cannot have different return types. C is a function with same name cannot have a different number of parameters. And option D is all of the mentioned. So it's asking you to choose which of the following are correct in C.
Option B.
Yeah, option B is correct. So a function with the same name cannot have different return types. But is that the only statement which is correct, can you have two functions with same name and different parameters in C? Like, can you write int sum and then give it a parameter, say int a b, and then you again have float sum and give it parameters float a comma float b? So in C, if you declare two functions with the same name, then it will give you again a compilation error. In C, every function needs to have a different name. Even if you change its return type, that is not enough. It's not enough to change only the return type or the parameter, number of parameter or the type of the parameters. Two functions in C need to have different names. And hence, all of the statements are correct. That is, you cannot have functions with same name with different return types, different number of parameters, different signatures. All of these are correct. Okay. If you will read C++ later sometime, then you will see there that C++ allows you to declare functions with same name and different parameters, which is called function overloading there, but it is not allowed in C. Okay, moving to problem number 3. Here you're asked that what will the function return? Okay, so you are not given that what exactly are the values of x and y.
Ma'am,
Yes.
ma'am, problem 2, can you explain once again, ma'am?
Yeah. One second, I'll open my whiteboard. Yeah, so here the question is saying that let's say you have this function int sum, which is adding two numbers a and b. Okay, so it is asking you that if you change, say, the return type of this function and write like this, or maybe you will, let's say, not change the return type. Let's say you then just change the number of parameters. Say now you have 3 numbers to add, say. So it is asking that are you allowed to declare all of these 3 different types of functions in C program or not? Like, can you have these three functions in your program in C or not? So in C, you cannot have these 3 function declarations in a program, because in C, every function needs to have a different name. Okay, so maybe you can call the first one as int sum. Okay, I'll just write it, maybe not here. So maybe you can rename it like int sum, because you're adding two numbers. Here you can say float sum, although the parameters also needs to be changed then, or maybe you will say is multiple sum, or whatever name you want to give, you can give. But the takeaway is that in C you cannot have more than one function with the same name. Each function needs to have a different name. So here the question is asking you to choose which of the statements are correct. The first statement is a function with the same name cannot have different signatures. That is, if there are two functions with the name sum, then they cannot have different signatures, which is true because there can be only one function with the name sum. There cannot be two different functions with different signatures and the same name. And B and C are also similar options. That is, a function with the same name cannot have different return type, different number of parameters. So in essence, all of these statements are trying to say here that a function in C, a function name in C is unique. Okay, two functions cannot have same name. Is that clear now? Okay. Okay, if it's not clear, then let me know. Otherwise, let's move on to the problem number 3. So here you're asked what is the return of what will this function return? So this is your function int func, and it takes two parameters, int x and int y. Here you are not given exactly the real values of these x and y, like x can be 5, y can be 6, or it can be 10, 20, whatever, but you're not given any value to this, so you cannot actually compute the real value, but you are asked that in essence what this function is doing. Is it multiplying the two numbers, is it adding these two numbers, or what it is doing? And you are given four options for that, a, b, c, d. Okay, and also you need to check that whether it works for any integers or whether it works for only non-negative integers. Non-negative means 0 and above, 0, 1, 2, and so on. So here the first if condition is if y is equal to 0, then return 0. Otherwise, if y equal 1, then return x. And if none of these two statements are true, then you go to the last, which is return x plus func x comma y minus 1. So it's a recursive function. Have you read about recursion? When a function calls itself, okay, that is called recursion. So here function 1 is calling itself, so it is a recursive function. Okay, and y is equal to so here there are two base cases. So base case means base case is necessary so that whenever you these two statements are true, one of these two statement is true, it will actually return. That is ensuring that recursion will terminate at some point of time. The program, if you do not have any base conditions, if you do not have one or two, then this will be infinite. uh, it can infinitely run, like there is nothing, there is no condition which will stop it from uh, which will ever stop it from executing. So a base condition is very important, and these first and second statement are the base case, and this is the recursive function call. Is the question clear?
Yes, ma'am.
Okay, then try to like in your either on a notebook or maybe in your just try to think about it, that what is this function trying to do. Any answers?
Option D, ma'am.
Option D, no, try again. There is recursion here. Just try to run it, like try to say assume two values of x and y, 5 and 5 or 5 and 6, whatever you want, and then try to run it once. Dry run it on a paper.
Option A, ma'am.
Option A, it's close, but it's still not correct. Okay, why is it A?
Ma'am, recursive function means a function call itself.
Yes, yes, that's correct. Yeah, that is correct. But why option A? So you identified that it is. So did that that it is multiplying these two numbers x and y, and how did you come to that conclusion? That's what I'm asking. Okay. So here we have this function. Okay. Let's try to see how it is. How does it work? So, first of all, you will get these two numbers x and y here. Okay, as an input, I'm going to write it as f of x comma y. I'm representing func as f only here. Okay, then you're first assuming that y is not 0 and y is also not 1, like y is some number which is greater than 1, then what will happen? You will go to this line number 3, okay, here, right? So in line number 3, what are you going to do? Like, what is your program doing? It is taking x and it is just taking that value x. Okay, it's like you are here, it is taking the value of x, adding it with the output that it gets by calling itself on the input x and y minus 1. So what has it done here? It has reduced the value of y by 1 while giving x as it is to its next call. Okay, now what will happen? On the next call, this function is what it's going. Now assuming again that y is still greater than 1, okay, first and second statement will still not be true. So in that case, here we again go to line number 3, and when we go into line number 3, what happens? We're again going to take the value of x, okay, and add it with f of x comma y minus 1. Okay, this will happen and this will continue, like you will continue calling the function will continue calling itself like this until when? Until y becomes 0 or y becomes 1. So y actually in this case, uh, this statement will never execute, sort of. Y will become, unless y is 0. So y will become 1 here, okay? And y will become 1. Let's say y became 1. There was some function called f x comma 1, okay? Where you also had x plus x. You called f of x comma 1. Now, condition number 2 will be true. So when condition 2 become true, what will happen? It will return x. So now x is returned. There is no more, here there is no more recursive call. So when there is no more recursive call, the function starts returning back. So function will start returning back, means this value is returned back here. So it will be added with x. So it will become here 2x. Okay, this value will be returned above. So now to explain it in a manner so that it is more clear to you, let us take a concrete example. Okay, I think if you are seeing this for the first time, then this is probably not so clear what I'm trying to explain. So I'll take a more concrete example here. Concrete means with some values of x and y. So if we take some values of x and y, which can be, let's say, I don't want the recursion to be very huge, so I will take say 5 comma 3. Okay, so 5 and 3 are assuming that our numbers here, which is 5 is x and y is 3. Okay, now here the on the arrow I'm going to write is 3 equal to 0, is 3 equal to 1. Both are false. Okay, so if both are false, we are going to the last statement, which is x plus f of x comma y minus 1. So it is 5 plus f of 5 comma 3 minus 1. So in this call, again, next call, we are going to invoke the function, like function is again executed. So again, it is going to check, is 3 minus 1, which is 2, is 2 equal 0, 2 equal 1. Both are again false. Okay, so it is coming here and to the line, to again line number 3, where it takes 5, add it with f of 5 comma 2 minus 1. Okay, which is 1. So now again this function is executed here. Now what is happening? Now y is 1. So we check, is y which is 1 equal 0, which is false, is y equal 1, which is true. So since it is true now, it will return x, which is 5. Okay, so now it returns 5 from here, which goes here. Okay, so what it will do, it will add 5 with itself, sorry, 5 with 5, so it becomes, so 5 is returned here. Okay, now this call returns here as 5 plus 5, 10. This call here returns here as 5 plus 5 plus 5. So this is your final, value, which is what? You are adding x with itself, y times, which is x into y. So you are actually multiplying these two numbers by doing the addition like again and again. Basically, you are adding x with itself, y times, to give you x times y. So this is concrete example, and I hope this is clear. If it is not, then let me know. And in general, it will proceed like this. Okay, I think these two are clear. Now the question says option A is x into y, where x and y are integers, or B, x into y, where x and y are non-negative integers. So far with what we have discussed, it can be either option A or B. Now which one is correct? For that, we need to look at the base case. So as I was saying that, or as you have seen here, right? If you do not have any base condition, like if your what is happening here, your function is calling itself again and again. Okay, and it will call itself until it hit the either condition 1 or condition 2. So when one of these conditions become true, then it will return. So it will start returning from here, like this backward arrow. Okay, blue arrow is showing that it is starting returning back. So in which is a base case. Okay, now it is important to have these base cases correct in any recursive program. Whenever you're writing a recursive program, always ensure that you have right base case. Now here the base case is saying that if y is equal to 0, then return 0. If y equal to 1, then return x. But what happens if y is equal to, say, minus 1? If you give it an input, if you give this program an input 5 and minus 1, basically you are saying, okay, multiply 5 with minus 1. So you expect it to give minus 5, but will it work or not? That's the question. So will it give you minus 5 or not? So it does not give you minus 5. Why? Because here y is minus 1. When you go and check condition 1, y equals 0, it will be false. When you go and check condition y equal 1, it will be false. And you will go into the recursion, which is going to subtract 1 from y, which is minus 1, minus 1, minus 2. And you will keep decrementing y again and again, and it will never become 0 or 1, because from minus 1, you will always go towards minus numbers, like more larger and larger negative numbers, but or smaller and smaller negative numbers actually, and it will never go back to 0 or 1. So your program will run infinitely. Okay, it will be wrong actually. And so therefore this program here works only for non-negative integers. It doesn't work for negative integers. So is this clear?
Yes, ma'am.
Okay. Coming to problem number 5. Okay. So this is the question, what is the output of the following C program? You have here two function declarations, void foo and f. Okay. They are not taking any parameters and their return type is void. Then you have a main, your main function, return type is int. Then in main you are calling f and returning 0. And these two function definitions are here. Void function is foo function is printing 2 and f function is printing 1, and it calls foo. So you are asked that what is the output of this C program, and these are the 4 options. A is compiler error on foo as it is not declared in main. B is 1 2, C is 2 1, and D is compiler time error due to declaration of functions inside main. Is the question clear?
Ma'am.
Okay, do you understand this program? So what does,
Ma'am.
yes.
Ma'am, second one, what is that void FOO?
Okay, so FOO is the name of the function. Okay, foo. Let's call it, like I pronounce it like foo. So it is the name of the function. Okay, and void is the return type of the function, and there are two parentheses here, these, and there is nothing is written inside them. That means the function does not take any parameters. Okay, and f is also, like we have written here a comma. Basically, I'm not very sure if this is the right syntax because I have never used this myself, but this is saying that f is also a function of type of whose return type is void, and it also doesn't take any input parameters. It doesn't take any parameters basically. So these are the function declarations. Okay, and these are the definitions of these two functions, and we are using function f here. We are calling f from main, and we are then calling foo from f, and inside f and foo we have two print statements. Is it clear now?
Yes, ma'am.
Okay, then what will be the output of this program? Is the program not clear?
Ma'am, B, ma'am.
Yeah, B is correct. Can you explain also? You can try to explain as much as you understand. So here, yeah,
Ma'am, in fourth line, F means function,
yeah, this is F.
ma'am.
Yeah, it's function call. So how do you call a function? You will write the function name and give it the arguments that it is, um, like the parameters that it takes. Here there are no parameters that it takes, so you have just written the function name along with the parentheses. So you're calling function f here. So your program will start from main. First, it sees that there is a function call. To function f. So it goes to function f here. The first statement is a print statement with this is your string that it needs to print, which is 1, and then a space. So it will print that on the screen. Then after that, it calls here foo. Foo is, it goes, the control goes to foo. Now foo has a print statement with 2. So then it will print 2. So so on your output screen, you will see 1, then space 2, and that is your option B. Any questions? Okay, let's go to next question. What will be the output of this program? Do you understand switch statement? Do you understand switch statements? So B, okay. Vansh, did you answer for this question or was it previous one? I think it was previous. Okay. Can you try to answer for this one also? And can you guys tell me, do you know switch, like are you familiar with switch statements in C? Like how do they work? I am not able to guess that whether you know or not. So can you just write it in the chat box that whether you are familiar with switch statements or not? Okay. Okay, then can you try to attempt this question and check? So this is the question. I mean, this is the program where you need to, you're asked that what will be the output of this program, and these are the options A, B, C, D. And you have to tell which of these 4 options is correct. Okay, so I'll give you a hint. So in C, what is the return? What does printf function return? That's the question here, because that will help. That will basically decide which one of the cases is going to execute, right? So printf returns the number of characters printed. It returns the number of characters that are printed. Now for printf C, how many characters will be printed? That's the value which will be inside this switch statement, and based on that you have to tell that which case is executed and then which is the other printf statement which will execute, like whether it's printf default, printf choice 1, printf choice 2, or what. Did the hint make it sense?
Ma'am, option C, ma'am. Default choice 1.
Default choice 1. Okay. Why? Why is that? Yeah, it is option B. Can you explain?
Ma'am, firstly, this statement of printf, normally normal statement printf C.
Yeah.
And ma'am, now basically it's a choice, much proper choice. So default option is printed.
Why default? So you're saying that default will be executed. So default will execute when case 1 and case 2. I mean,
हाँ, yes ma'am. Switch when जब आपका कैरेक्टर वो switch उसके अंदर ऑप्शन में गिवन नहीं हो,
right.
कौन से केस प्रिंट करना है?
Yeah, right. So when the value inside the switch statement does not match any of the cases, then you go to default, right?
Yes ma'am.
So it is neither case 1 nor case 2, so default. Now here I'm saying that printf returns the number of characters printed on the screen. Here it is taking as a string which is has only one character, C. So it will return 1. The printf function, which is a library function, it returns the number of characters printed. So here it is going to print one character on the screen, which is C, right? It's also printf. Although it is being used inside this switch, it is going to print something. It's not going, it is not possible that it doesn't print. So it will print C and return 1, which is the number of characters printed on screen. So then, is that clear? Then what will happen next? Which case will be executed? Now, I told you that printf returned 1. Now, which case will be executed?
Ma'am, choice 1.
Yeah, case 1, and it will print choice 1. So then what will be the answer? A, B, C, D. Which one?
A.
No, but you forgot that it also printed C here, right? Is that clear? It printed C here. Then it returned 1. Then using that 1, you chose to execute case 1, where you printed choice 1. So in like the entire output of your program is C choice 1, which is option B. Is that clear?
No, ma'am.
No?
Again, how come choice one is printed?
What's the question?
Ma'am, how come choice one is printed?
Okay. Okay. I'll try to write this down. I can try to execute it also and then try to problem. See? Okay. I think that's the program. Yeah. So this is the program. Okay. Now let's first try to run this. Okay, this is your output. I haven't this is gone now. This is your output here. The output is C choice 1. Okay, now I'll explain to you why is it so. So this is your when your program start executing from main, first statement is your switch statement is goes inside this switch value, which is actually not just the normal like value variable here. In fact, it is a function call. It is calling printf to print C. Now what does printf do? So as you can see on my screen, printf is a function where it is returning an int and it is taking as parameter some uh, basically an array of characters or a string. And so what does it return is basically the number of characters that it printed on the screen. Okay, now in this case the string is C, like it has only one character C. Okay, so now it is going to return 1. We can also test that, like let's say int x is equal to printf C. I'll remove this from here. I'll write x here instead, and I will just say here what did printf return. X is equal to your x. Okay, so we are asked like checking here what did printf return. So it should return 1 because it printed 1 character here. Did it do from here? Okay, sorry, I did not specify. So sorry about that, I should have added more some new line characters here. Okay, oh my god, Let's just message it up. Land it here. Okay, yeah. So you had this function called printf, which is taking this string of length 1 character, basically only C. It returns some value, which is, I'm saying, is the number of characters that it prints. I'm storing that it in variable x. Now we are now printing what is the value of x, and as you can see on the screen, the value of x is 1. That is 1 character. It printed 1 character. So when you use that value 1 in your switch, you will go to case number 1 here, which is calling printf function to print choice 1. So your program, let's remove these extra statements now because they will change the output of your program. So originally your program is this, okay? So it will print C choice 1. So it will print C also because that's the first print statement that is executed, and then case 1 is executed with another print statement which is choice 1. So it prints C choice 1. Is that clear now?
Yes, ma'am.
Okay. Okay. Give me a second. I think my screen is. Okay. So again, you have this program on the right hand side.
Ma'am,
Yeah.
sixth problem we will not do, ma'am.
Okay, okay. I think this slide is blurred. Yes. Okay, yeah. So here is the program. It is asking again output of the program. You have declared a character here, assigned it value 0. Then you have for loop here, which is using this character, okay, incrementing it on every iteration, checking whether it is less than 127 or not. And if it is one less, if the condition is true, then you are going to print the value of x. So now what will be the output of your program? And there are 4 options: A, B, C, D. A is compilation error, or 0 to 127, or 0 to infinite, 0 to 127, then minus 1 to 28 to 127, and so on, or 1 to 127.
See, ma'am.
Which option?
See, ma'am.
C. Yeah, that's correct. How?
Character x equals to 0, ma'am.
Yes, yeah.
For x equals to 0, 0 less than or equals to 127.
Yes.
X plus plus means x value is 127. 127 plus plus. Here is increment, ma'am.
Sorry. Can you explain again? I missed the last line.
X less or 0 less than or equals to 127.
Right, right, that's correct. Then,
X plus plus. That one is increment, ma'am.
yeah, that's an increment.
Here x value is 0 means 0 plus plus. That's all.
So how does that say that it's option C? I mean, why option C, not B?
Ma'am, it should be option B.
Okay. Why?
But like normal working of for loop start with 0, and when we increment it till the value equal to 127 or less than.
Yeah. So then what will happen when x is 127 and you add 1 to it?
Ma'am, it will come out of the for loop.
Okay. So when you add, so when it becomes 127, so actually here a character is represented with 8 bits, okay, in binary, right? A character is 1 byte, right? So a character is 1 byte, that is 8 bits. So initially it is 0, value is 0. That means all of the bits are 0. Then when you add 1 to it, then the character will become 1. Then you add so on, you will add 1 to it on every iteration till x becomes 127. Now what will happen when it is 127 and you add 1 to it? It actually becomes a negative number. When you add one more time 1 to it, then it will overflow, and the next it goes into 1 and it becomes a negative number, which is minus 128. Try this on the whiteboard. So what I'm saying is, okay. So initially x is equal to 0, okay, which is 4 bits, sorry, 8 bits. All are 0. This is the binary representation. And x is a character here, okay. It has 8 bits, 1 byte. Now when x becomes 1, it will be added to this binary. In binary it will be like this. Then you will add one more, it will become this, and so on. So you will keep adding values till 127, at which point it will be this value. So this is representation of 127, okay. Now when you add once more, if you add 1 to it, now what happens is, if you will add one more 1 here, then in binary, when it is 1 and 1, it will result in 0 with the carry of 1. Then 1 added with 1 again 0, carry 1. 1 added 1, 0, carry 1, and so on. Now this number is actually minus 128. Okay. And that is why your program here, when you add one more 1 here, it becomes minus 128. So when you check the condition here, whether x is less than 127, it will still be true. And it will then print minus 128. Now if you add plus 1 to minus 128, it will then become minus 127, minus 126, and so on till 0, and again it will become 127 incremented, then it will again become minus 128, and so on. So it will become an infinite loop. Okay.
Okay, ma'am.
Okay.
Ma'am, which option is correct, ma'am?
See, it will print 0 to 127 as you were saying correctly, but after x becomes 127 and you add 1 to it, it will become minus 128 and not like 128. And since it becomes negative number, the negative number is less than 127, so it will continue, the for loop will continue, and it will continue basically forever, because the cycle will again continue. As soon as you again reach to 127, then it will again become minus 128. So it will continue forever. It's an infinite loop. Okay, coming to next problem. Here you have the main function here from where your program will start executing. You have a print statement which is printing the output of this function fun. Function is taking as input value 10, and you have to tell what will be the return value of this function fun which you are going to print. Okay, so you try to execute this function fun, okay, as when n is equal to 10, and then answer one of the options from here. Is the question clear?
Ma'am, again once repeat, ma'am.
Okay, so this is your main function. Okay, your program will start executing from main, and then your main function is first calling print function, and inside the print is taking as an argument the result of function fun. Okay, now fun is being called here with value 10. Now you have to tell that what will be the return value of function fun when the input value of n is 10. So just focus on this fun function here and tell me that if n is equal to 10, then what will it return? You have to execute these for loops and increment the value of sum accordingly, and then you have to tell what will be the value of sum.
Ma'am, is it option D?
D. No.
Yes.
Try once more.
Ma'am, option B.
No. Once more.
A, ma'am.
Yeah, A is correct. How is it A?
Ma'am, for I equals to 1, ma'am.
Yes.
Here I value is 1 means 1 less than or equals to n, ma'am.
Yes.
I plus means 1 plus, ma'am. That's increment.
Yes.
Next for j equals to I, ma'am.
Yeah.
I less than or equals to I.
Yeah. Okay. Go here. Okay, one thing that I would like to, I think I discussed this previously in one of the classes, but I want to tell it. It's very important for you to understand, sorry, not how for loop works, like basically. So when you have this, look at this side, okay? So when you have this for loop, say int I is equal to 0, I is less than say 5, I plus plus, okay? And let's say you're just doing nothing but just printing the value of I here, okay? Now, in this, how does this for loop executes? So the ways it executes is that your control will enter the for loop here, okay? I is initialized with some value here, which is 0. Then after that, it checks this condition, whether this condition is true or not. In this case, 0 is less than 5. Then it goes inside. And then it prints the value. Here it is printing some value, okay? Now, on next iteration. So in the first iteration, we never do the increment, okay? In the first iteration, there is only initialization and condition is checked. And then if the condition is true, you go inside the for loop. You do not increment the value. Now, when you, on the second iteration onwards, you will first increment, then you will check the condition, and then you will enter. Okay? And this blue flow, like control flow, this blue side control flow happens on all iterations except the first one, while the red control flow happens for the first iteration. Okay, now I hope that is clear, so I will erase that. Now this is your question, which is on the left hand side. You are given here value 10 as your input. Okay. And now first in your function, you are initializing values. You have declared one variable sum, initialized it to 0. You have declared two other variables I and j, which are going to be used as iterators for your two for loops. In the first for loop, you are initializing I equal to 1. Then you check I is less than equal to n, where n is 10. So I is 1, 1 is less than equal to 10, which is true. So you go inside. Okay, here j is equal to I. You set j equal to I, so j becomes 1. Now you're checking j less than equal to I, which is true because you just set it to I. Okay, now you will add to sum the value of j, which is nothing but I. So if I can so let's say complete for now, let's say it is j only, and then you go back and you increment j value, so it will become I plus 1. Now this condition will become false. Now I can actually simplify this code. Basically this is very if I can simply basically write it like sum is equal to sum plus I. This entire for loop, second for loop, I can just in place of this, I can delete this and I can just write this one statement, which is sum is equal to sum plus I. Is that clear? Because the inside for loop is running only once, and what is it doing? It is just adding the value of I, which is writing which here we have written as j, to sum. So I can simply write it as sum is equal to sum plus I. Is that clear?
Yes, ma'am.
Okay. So then the program becomes very simple now. So you have this for loop which is running the let's say that this for loop, so we have deleted this for loop. In place of that, we only have this statement sum is equal to sum plus I. So you have only one for loop, the first one, which is running from I equal to 1 to I is less than equal to 10. So it is running from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is it going to do inside? Inside, initially sum is 0. So in sum, you are adding the value of I. So basically you are adding the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this program is then adding all of these numbers from 1 to 10. In the first iteration, sum was 0. Okay, I'll just write that 1 or 2 iterations. In your first iteration, sum will be 0, so it will be 0 plus 1. So now sum is equal to 1. In your second iteration, sum is equal to 1. Sum is currently 1 plus current value of I, which is 2. So sum will be 3. Then in your third iteration, it is sum is equal to sum, which is 3, plus the value of I, which is 3. Okay, the sum is equal to 6, and so on. I should write here not 1, 2, 3, but maybe I can write here I is equal to 1, I is equal to 2, and I is equal to 3, and so on. So it is adding the numbers from 1 to 10, and that is being returned here sum as sum. So 1 to 10, if you add the numbers, that comes out to be 55, and hence the answer is option number A. So now just a very simple question. If I change this condition here and make it I is less than n, then what will be the output of this program?
Ma'am, once repeat, ma'am, that question.
Yeah, I'm saying that originally the program had here the condition, if condition, sorry, not the if condition. The condition here is I is less than equal to n. This condition is I is less than equal to n. Now I'm saying if I change this to I is strictly less than n, and your n is still 10, okay, you're still given input 10, then what will be the value of sum here, which you are going to return? What will be that value?
45.
Yeah, that is correct, because now,
45.
yeah, because now the last iteration is not going, last iteration which is going to run is for I is equal to 9. Okay, that's correct. Let's move to the next one. Here, you are again given some function named find, okay, which takes two input x and y. Now it returns some value, okay, this is the ternary operator. Now what the ternary operator, this is the syntax for a ternary operator. It is very simple. If you haven't seen it before, like it is very simple. What it is like an if and else condition, okay. So this is your condition, x is less than y is like your condition. If the condition is true, then this value will be returned. The first value, which is just after the question mark, this is your true value, and the value after the colon is your false value. So if x is less than y, then return 0, else return x minus y. That's your program. It's not, it's just doing this very simple thing, that if x is less than y, return 0, or else return x minus y. Now let a and b be two non-negative integers, okay, which are greater than equal to 0. Then the call find of a comma find of a comma b, which is like you're calling first find on with values a b, then the output of that find function you're using again to call another find again with a comma that output. Now it's asking you, then this call can be used to find the, can it be used to find the maximum of these two numbers a b, the positive difference between a and b, the sum of a and b, or option D, the minimum of a and b. So what you can do to solve this problem is that maybe you can assume some value of a and b, say 5 and 2, and then you can see that if you will execute this, try to execute this and see the result which you get, whether it is the maximum of a comma b or minimum, or which of the following is true. Or you can try to understand what the program is doing. Did you try?
Ma'am,
Yeah.
I think option A, ma'am.
Option A. Okay. Why? I mean, did you take any, how did you decide? Did you take any concrete example?
I think it's option D.
Yeah, option D is correct. How did you decide?
Yes, ma'am, I have taken 5 equal.
Okay, yeah. Okay. Will it also work for 2 comma 5? Maybe you can check that as well. Others can also check, like take two numbers and check. First take x, say smaller than y, then take y smaller than x and see if returns the minimum or not. Take them as equal and see what it returns.
Yes, ma'am, it is also working fine with 2 and 5.
Oh, yeah, okay. What about two equal numbers?
Ma'am, it returns the same value.
That's the correct answer, right?
Yes.
Okay. Okay, so that's correct. So your function is like this, it returns this value. Okay, now we are question is that will this function, if this is the function int f int x comma y, so it's find, but let me just call it f for now. And if they call it find, then the question is if we do find of a comma find of a comma b, then what does it return? Okay, so let's take here three cases. Case one is a is less than b, case 2 is b is less than a, and case 3 is a is equal to b. Okay, so in all of these cases it should give the correct answer. So the answer is, say, minimum, it returns the minimum of the two numbers. And we can take two concrete values here. Let's say for the first case a is 2 and b is 5. Okay, so first find what are we have chosen a is equal to 2, b is equal to 5. So first find, what will the first find function return? So you will call find of 2 comma 5. So you'll come here, 2 is less than 5, which is true, so it returns 0. So it will return 0. Now you will use that value 0 in your next call here. Okay, now you call find of 2 comma 0. So 5 of 2 comma 0, you come here, 2 is less than 0, no. So you return 2 minus 0, which is 2, which is the minimum of the two. Okay, now the second case where you take a is equal to 5, b is equal to 2. So you call find of 5 comma 2. Okay, you're first passing a, then b, so it's 5 comma 2. So 5 comma 2, 5 is less than 2, no. So you done sorry, did I do something wrong? 2 is less than 5. Yeah, I did the first one wrong, so I got that. Okay, so in the first one, this I did wrong here. find of 2 comma 5. So this condition will be checked, which is 2 is less than 5, which is true. Okay, I'm just it was correct only. So find of 2 comma 0, which is 2 is less than 0 is false, so it will be returning 2 minus 0, which is 2. Okay, now sorry, coming back here again, find of 5 comma 2. So 5 is less than 2 is false, so false means you will return this, which is 5 minus 2. 5 minus 2 is 3, so it will return 3. Okay, now again you call find of 2 comma 3. It's going here. So 2 is less than 3.
5 comma 3.
Oh yeah, thanks. I would have been stuck in the next step anyway. Yeah, so it is find of 5 comma 3. So here you check the condition, 5 is less than 3, which is false. So you again go back to the false condition value, which is 5 minus 3. So you return here 2, which is also correct, like it's the smaller of the two. Now what happens when these two are equal? Let's say they both are 2. Then you will call find of 2 comma 2. Find of 2 comma 2. So this condition is false because it is always checking for a strict inequality. So it will return 0. Now again you are going to use this value, find 2 comma 0. So now again it is strict inequality. It will, what will it do? 2 x is less than 2 is 0. 2 is less than 0. God, I'm so confused, right? Between true and false, I just keep getting confused. Okay, so the first value is find 2 comma 2. So 2 comma 2, this become false. So it will not, it will go here, just this false. So it will be 2 minus 2 is 0. So that is how you get this 0. Then again, you when you are executing this function call here, it says, okay, 2 less than 0, it's false, so you go here, which returns 2 minus 0, which is 2. Okay, so in all of the cases, if you have these two numbers a and b, I mean there are 3 types of cases which are possible. So in all of the cases, this function, find of a comma find of a comma b is going to return the minimum of the two numbers. That was the question. So is it clear?
Yes.
Okay. Moving on to the next one. Okay, this is a Fibonacci. Are you familiar with Fibonacci series? Yes. Okay. Are you familiar with Fibonacci series? Okay, I'll just quickly explain that before the function, before that program, because that's like a prerequisite for that. So Fibonacci series, you will come across this number of times again and again in any programming class or something. So it is basically just a series of numbers. Okay, so it's like 1 1 2 3 5 8, then 13, then 21, and so on. Now what is happening here? So you take the two numbers just before. Now how do you get this number? To get this number, you'll take the previous two numbers and add them, and that's how you will get this current number. So what is that? 34. Okay, so let's verify this, that this condition should always be true. So how did you get 2? 2 is 1 plus 1. So you added these two numbers to get this. 3 is 1 plus 2. You added these two to get 3. 5 is 2 plus 3. You added 2 and 3 to get 5. 8 is 3 plus 5. 13 is 5 plus 8. 21 is 8 plus 13, and 34 is 13 plus 21. So you can, so this is the Fibonacci series. It's like an infinite series of numbers which you compute. So to get the next number, you add the previous two numbers and you can continue like this. So this is your Fibonacci series. The first number is 1, the second one is 1, and after that you can just add to previous two numbers and to generate the next number in the series. Is that clear?
Yes, ma'am.
Okay. So now this is a program which is given to you in this problem to generate the Fibonacci, nth Fibonacci number. Okay, it is saying, okay, let's say like here, this one, this is the first Fibonacci number, this is your second Fibonacci number, and let's say I ask you, okay, tell me the Fibonacci number 50. Okay, how will you find that? So how will you find Fibonacci number 50? So I'm saying,
Somehow 48, 49.
right. So you have to find Fibonacci number 50. So what you are going to do is that you are going to calculate Fibonacci number 49 and Fibonacci number 48. You're going to calculate these two, add them. Now, but your problem is not solved because now you have another two problems. Earlier you had one problem, that is you want to find Fibonacci number 50. Now you have two problem, like you need to find Fibonacci. You're saying, okay, if only I knew what is Fibonacci 48 and what is Fibonacci 49, I can just add them and get the number. Now you have to do the same for Fibonacci 49. You have to find what is Fibonacci 48 and what is Fibonacci 47. If only you knew what is 47, 48, you can add them and you can get Fibonacci 49. So till when will you do this? So you know that Fibonacci of 1 is 1, Fibonacci of 2 is 1. Okay, these are the two things that you know. So you will do this until you reach Fibonacci of 1 or Fibonacci of 2. At which point you can say, okay, I know Fibonacci of 1 is 1, so I can return that value and I can return this value. And then you can like go back in the tree and calculate this. So I'll just give a very small example. Let's say you have to calculate Fibonacci of 4. So for that, you will calculate Fibonacci of 3, Fibonacci of 2, right? What is Fibonacci of 4? It is Fibonacci of 2 plus Fibonacci of 3. Now, how do you calculate Fibonacci of 2? You already know because Fibonacci of 2 is 1. So you don't need to calculate this. You just return this value here. Okay, it is 1. But you do not know what is Fibonacci of 3. Okay, so then you calculate here Fibonacci of 2 and Fibonacci of 1, which is the previous two numbers. Okay, now you know both of them, right? You know that fib of 2 is 1, fib of 1 is also 1. So you are getting 1 from this side, 1 from that side. You add both and you will get fib 3, which is 2. And you then return that value above. From this side you are getting 1, from this side you are getting 2. Okay, so you will just add them and you will get here 3. So is it what you have in the series? Yeah, that's right. So fib of 4 is 3. So this is how you will compute Fibonacci number. So if you have calculating for 50, that will be a very huge tree in this sense. Okay, so and what is happening here? You are actually calling the function itself. You wanted to compute for 4, so you are saying, okay, I need to compute for 4. but let me first compute for 3 and 2, which is a recursion. Okay, you are computing for the smaller values. Now you are here given a recursive implementation for this. That is, you have this function int Fibonacci taking the value, input value n. Then based on the input value n, you have some switch case statement. Although there are other ways of implementing this, but this is the implementation you are given in the program, in this question. So you will, like, it is saying, okay, switch to n. So there are two cases here, case 1 and case 2, which are written here. In case 1 and case 2 basically are not doing anything. So you will fall through and go to the last statement, which is returning 1, which is same as what I just explained, okay, in that tree, that if you are asked what is the value of Fibonacci 1, you return 1. If you are asked the Fibonacci of 2, then you return 1. If it is not 1 or 2, then you are going to the default case where you are returning the Fibonacci of n minus 1 plus Fibonacci of n minus 2. So is this program clear?
Ma'am, if it passed value 10 and n equals value 10,
Yeah.
then it will directly go to default option, right?
Yeah, it will go to default.
So there is no option of returning the value of 1.
No, but as you can see here, it goes to default. Then what's inside default? It is saying return Fibonacci n minus 1 plus Fibonacci n minus 2, which is, what is n minus 1? It is 9. And what is n minus 2? It is 8. So it is going to call Fibonacci of 9. So now you're again coming back here. Then you're saying, okay, what is Fibonacci of 9? You again go to the switch, which is 9. So you again go to default, which is saying, okay, what is Fibonacci of n minus 1, which is, what is Fibonacci? Now, currently n is not 10, it is 9, because it is another function call. It is a new function call with value n, with value 9. So now n minus 1 is 8. So you again go back and you again say, okay, ask, what is Fibonacci of 8? You come here, now you want to compute what is Fibonacci of 7. So you will go back until it becomes 1 or 2. When it becomes 1 or 2, you will not go to the default case. You will go to case 1 or case 2, at which point your program will start returning from the leaf nodes as I showed in the tree. Okay. It is when your program reaches these cases, it will start returning values. When it returns value from Fibonacci of 2, it will come to Fibonacci of 3. When it returns here from Fibonacci of 1, it comes to Fibonacci 3. Now Fibonacci 3 function call will return the value to Fibonacci 4. Fibonacci 4, when it is computed, will return the value to Fibonacci 5, because it was called from Fibonacci of 5. Does that make sense?
Yes, ma'am.
Okay. If you do not understand recursive program, I mean, it's okay. It's difficult to understand. I can explain again. So I hope the program is clear. Any other question in the program? So I gave you that example, right? 4. When let's say you're trying to compute 4, int 4, value is 4 here. Okay, assuming it's 4, you will come here, switch 4. Go to default, where you are saying, okay, Fibonacci of 3 plus Fibonacci of 2. So Fibonacci of 2, let's say first you go and try to solve this. You will come here. You will go to case 2, which returns 1. So 1 is returned here. It's done. Now Fibonacci of 3, you'll go here, Fibonacci of 3, switch 3, default is executed, which is Fibonacci of 3 minus 1, which is 2, and Fibonacci of 3 minus 1, which is 2, and 3 minus 2 is 1. And when you will call these two function calls, they will return 1 and 1. 1 and 1 will be added and becomes 2, and it will be returned back because there is a return here. It will be returned back. This return is very important. Okay. If you forget this return statement here, then your program will not work correctly, basically. It will just return 1 always. So now, if the program is clear, if not, you can ask me again. If the program is clear, then try to answer this question. The function above has a flaw that may result in a serious error during some invocations. Okay, it is saying it has some flaw which can result in some error during some invocations, not all, like sometimes it's saying. So which one of the following describes the deficiency illustrated above? Option 1 is, for some values of n, the environment will almost certainly exhaust its stack space before the calculation completes. Second is, an error in the algorithm causes unbounded recursion for all values of n. C is, a break statement should be inserted after each case. Fall through is not desirable here. And D is, the Fibonacci function includes call to itself. This is not directly supported by standard C due to its unreliability. So first I want to ask you about options C and D. Are they correct or not?
Which options?
Option C and D. Is option D correct?
No, ma'am.
Yeah, that's correct. This statement is not correct because recursion is allowed in C. A function can call itself in C. Okay, so option D is not correct. Now, what is option C? It is saying a break statement should be inserted after each case. Fall through is not desirable here. So the question is basically saying that since there is not break statement, it's not correct. So is it true? Is it required to add a break statement here?
No, ma'am.
Yeah, that's correct. You don't need a break statement here. So it's option C is incorrect. So now option B, an error in the algorithm causes unbounded recursion for all values of n. Like it's saying, okay, take any value of n and it will lead to a unbounded recursion. Means the program will never terminate. Means the recursion is infinite. Now, to prove that this statement is incorrect, like B option is incorrect, just take the value of n as 1. So if value of n is 1, then you will come to switch 1. Switch 1 is case 1. So you will go to here, return 1. And the program and your function returns. It is not an unbounded recursion. It will not cause an unbounded recursion, okay? So B option is also incorrect. Now option A, for some values of n, the environment will almost certainly exhaust its stack space before the calculation completes. Now what is a stack space? Are you aware of that?
Yeah, ma'am, part of memory, stack and queue.
Yeah. So your program, when it runs, it has a memory called stack where it basically keeps the function data. Okay, like it keeps the variable values and the functions which I've called there. Now, how is that impacted due to recursion? That's what we need to understand to answer this question. So let's say you have a very simple program here, main, Okay. This is your main function. The main function calls say foo function. Foo calls say bar function, and then bar will return to foo. Foo will return to main. Now this is your stack. Okay. This is your stack, which is in I should represent it differently actually. This is your stack. It's in your program memory. Okay. Now what happens that a chunk of memory is allocated, like it is there where your function like values of functions are kept. Like main might have some variables, say a b c d. Those variables are stored here. Okay, that's your main. Now when main calls foo, that time another entry is made on this stack to store the values of function foo. Okay, say it has some variable x, y, then you called bar, foo called bar, so again one more function entry is made on the stack. It's called function activation actually. So again you have this. So whenever you call a function, the stack is filled with a function activation. Like some space is allocated on the stack for that function. Okay, from that particular run of the function. Now when a function finishes its execution, when it returns, then you will delete that function activation. It's deleted from the stack. Now when foo returns to main, then the function foo's activations are returned from the stack. When your program terminates, then your whole memory is basically freed, so everything becomes empty on the stack. The stack is empty now. So this is what happens when a function calls another functions. Okay. Now in coming to this recursion, now what is happening here? Say Fibonacci of 50. To compute Fibonacci of 50, you have to call Fibonacci of 49. To compute 49, you compute 48, then 47, then 46, 45, and so on. So all of these function invocations are stored on the stack. Okay, so you will have this huge stack where you are going to add one entry for every function call like this, and so on. So it is saying that imagine if your number n here is very large, say 5,000. I don't know actually for what value your program may run into problems, but since your option is saying that for some value of n, so assume that the value of n is very large, say 5,000 or maybe 1 lakh or some million, then it can happen that your stack can get completely filled. And once your stack can get completely filled, your program will run out of memory. And when your program runs out of memory, your program will be terminated. Like it just ran out of memory. So you can also basically while you will write programs, now recursive programs, if you do not write the recursive program correctly, and if you do not write a base case correctly, like that is which ensures that recursion is not unbounded, you will run into this problem where you will get this error on your terminal that which says, okay, stack overflow. So which means that your stack was filled with a lot of entries in this fashion when you called one function after the other, and at some point your stack did not have any more memory to execute the other function call. So although the program is correctly written here, in this case, the program is correct, but it is saying that for a very large value of n, or for some value of n, depending on how much memory your stack has, the stack will eventually exhaust its memory. And at that time, your program will basically run into problem like Stack Overflow problem, and that is certainly that can actually happen. So the option is just saying that for some value of n, the environment will almost certainly exhaust its stack space before the calculation completes, because this depends on your stack memory, and you can always choose a number which is such that it can just exhaust the stack memory. So better way of writing program in that case would be to not write a recursive program, but to write a non-recursive program to compute the Fibonacci numbers. Now, which is also very simple, because all you do is to add the previous two numbers. And I will leave that as an exercise for you to find out how you can write a non-recursive Fibonacci number computation program. But is this clear? Whatever I said just now about stack overflow problem?
Yes, ma'am.
Okay, thanks. Okay, so we are going to do this one last problem, which is asking you what is the output of the C code given below. So I'll just go over the program very quickly. Here you have declared one function, name is func. It is taking as an input an array of float. Okay, the array name is age, and it returns a value of type float. Now inside your main function, you have declared one result variable which is of type float, and there is a age array. So age is an array of float. Okay, basically means that it is an array which stores values of type float. So what is float? Float is data type in C to represent the rational numbers, like basically the real numbers, that is the numbers which have decimal digits, right? Like 23.4. So here, here you are using this set of like basically this is the syntax where one of the syntax to initialize the array, where you use this set of curly braces and you write some values inside it, separated by commas, and then your array, which is age here, will be filled with these values. Okay, so the value at index 0 is 23.4, value at index 1 is 55, and so on. So your array has 1, 2, 3, 4, 5, 6, 6 values. So the size of the array is 6. Yeah, the answer is correct. Vansh, which what you wrote in the chat box. So now your function, so your program here is calling func with giving it as an argument the array age, and the result is going to be stored in this result variable. Basically, the return value will be stored in this variable result, which we are going to print here. Okay. Now, what does this function func is doing? It is declaring one variable result and another float variable sum, initialized it to 0.0. Then there is a for loop starting from 0 till I becomes less than 6. It is going to add the values in the array at index I with the current value of sum, and sum is changed here. Okay, and then finally it takes the value of sum divided by 6 and store it in result, and then return the value of result. Now you have to tell me that what will be printed here. Punch has told me 27.08. Can you can you please like unmute yourself and explain that? I mean, if it is possible to unmute yourself. Okay. Okay, no problem. Harshita, did you understand the program?
Yes, ma'am.
Okay, what is it doing?
Ma'am, it is basically running a for loop, and in which it start adding. Initially, it start adding
Yeah,
all these numbers,
yeah,
and lastly, it is divided it by 6.
right. So it is dividing it by 6. So all of these numbers, 24.4, 55, etc., these numbers are added in this for loop, and then it divides by 6, and then it returns the result, which is printed here, and which Vansh correctly answered is 27.08. So you can verify that.
Ma'am, my answer is like 26.58.
Okay, it should be 27.08. How did you get that? Did you can you check that you added these numbers correctly? You can use a calculator.
No, ma'am, I think that there is calculation mistake.
Yeah. Just check once.
Yeah, ma'am, it is 27.08.
Okay. Yeah. Okay. Thanks. So to answer one question, if different questions are discussed in different sessions, I think same set of questions are discussed in all of the sessions. There are like quiz questions followed by some programming questions. Today I don't have time, like we now it is already 8, so I think I'll discuss the programming questions in the next class. But okay.
Okay, ma'am, thank you.
Okay, thank you so much for joining. And do you have any question? Okay, I'll just stop the recording.